Hello and welcome. Today we're going to be going over some of the code from Chapter 3 of the Black Hat Python book. And if you're following along with this series, yes, I did skip the last bit of Chapter 2. I don't want this series to be a full in-depth coverage of every bit of code and every project from the book. Instead, I want it to be something that kind of highlights some interesting things to get you interested in it. Maybe delve in a bit more, maybe get the book. So with that, let's get in here and we'll take a look at what we have going right now. So in this folder, I've got 3 files here. We've got scanner, we've got sniffer IP header decode, and sniffer. As of the time of this recording, I have uploaded these all to the GitHub, which there will be a link down in the comments. So first thing we're going to take a look at is the scanner. We're importing some pretty standard libraries for this stuff. Subnet, I've got it set to what my subnet is here at the house. And then we have a class IP. Now, kind of a quick breakdown for this. What's happening here is that when it captures the IP, or the packet, when it captures the packet, and it grabs the header information, this breaks that information down and saves it into different things. The biggest one, or there's 3 of them, that we're going to be focusing on with this code, and this here, number 6, the protocol number, and the last 2, source and destination. As you can see here, this next bit of code, it takes that source and makes it into a human readable IP address using the IP address library. And if you haven't taken time to look into this IP address library, I highly recommend it. There's a lot of useful things in it. And then we go and do the same thing with the destination. Now here, this tool is only going to be looking at ICMP, so things like your ping, TCP, and UDP. And here is if it comes across an ICP packet, this is just grabbing information from that. And this UDP sender, because there is one thing right here that I find interesting talking about the IP address library is using the IP network module in it and passing that subnet that we set at the beginning and doing the .host. What this will do is it will make a list of every IP address available in that subnet. So if you ever are needing to just cycle through IP addresses and you know the subnet, this IP address library and functions here is a really great way to make a quick little list with that information. And then we get down to the scanner here. Now, in this one, I've left it the way the original coders had intended for it, whereas it looks for the host, gets the OS name, see if it's NT, meaning it's Windows, and it sets it to this IP, or else it sets it to ICMP. And the other bits of code that we're going to be looking at actually added a function to where you can select between the 3 different types of protocols when you run the program. I'll show you that when we get to the other codes. So here we're just setting up a socket with raw, your IPv4, and then it prints out this hitting promiscuous mode, so in NT it'll get that set up. And then here's the heart of it. This is where it will just sniff traffic until it finds a packet. And this is, like I said, specifically looking for ICMPs, ping requests, and things along that line. And this just processes the information out and says the host is up. And then once we hit Control-C on the keyboard interrupt, it will stop. And it'll print out a summary of the hosts that it found that are up. And then in my testing, I had to hit Control-C again to actually get it to stop, or else it keeps sending packets out. So down here, we of course have our intro. So this is checking to see if we pass the IP argument of the local machine that it's going to bind to. So if you don't pass one, it just automatically defaults to this. So you can set that as your own IP, or you can take this out with another trick I'll show you in the other scripts. I left this in here in case anyone's still not too familiar with how to handle arguments on the command line for Python scripts. A decent little example. Here it sets up the scanner, it'll wait 10 seconds, and then it starts the UDP sender using the threading process. It starts it and then starts the sniffer. Okay, so that was a quick little run through of that one. Now before I run it and show you, I want to run it in conjunction with this other script, sniffer. We're going to take a look at it real quick. And this one's much shorter and much easier. We just got socket and OS getting imported. And then we'll focus down here on the main. Now here is the trick I use to get the IP address of the local machine. We just use OS, the popen function. We run the command ifconfig eno1. Now, of course, since I'm running ifconfig, this is only going to work on Linux machines. You could set this up with this little if OS name has an T. You can do the appropriate one for Windows. But I don't have any Windows machines. Everything is Linux, so I just go ahead and do that. And if you didn't know, when you run ifconfig, you can actually give it the interface that you're looking for, and it will just print off that interface information. So we take that and we'll pipe it over here to AWK. We'll look for the line that starts with inet, which that's going to have our IPv4 address, and that address is the second part of that line. So we'll just print that, read back that information so it doesn't print to screen, and we can actually set host equal to it. Make this all a string to make sure it's good, that the program can use it, and we'll strip off the new line because it will return a new line character. And then packet type, this is another thing I added. It asks the user for some input, so you can press 1 for ICMP, 2 for TCP, 3 for UDP. And then it prints out listening on host, it'll show the IP address, and then it starts up the main function. Now up here, if it's NT, like the other one, it'll set the socket to this, which is what you'll need for Windows. However, if not, it'll go through and look for the user input, and it'll set it to the appropriate packet that we're looking for. And then all this does is set a socket up on the host to listen, and here it waits to receive, and then it will close out the socket on the Windows NT. At a quick glance, you can see this is only going to read one packet at a time. You could put this into a loop. So this part right here, this print, you could do while true and then have it break off user hitting Control C. There's a few things you can do, but I'll let that alone for right now. If we come over here, and all of these you got to run with sudo because it's creating a port, binding to it, manipulating packets, all that type of stuff. And we'll get my machine's IP address in. So there it's firing off. Okay, so I let that run for a minute, and now we're going to run the sniffer down here and get that. And we're going to select ICMP. Okay, and it grabbed a packet on the way out. Actually, it got the packet on the way back. And you know that come from our program because it says Python rules here in the message. And this first IP address, that is the source address. And this one is the destination address, if I remember correctly. And for this up here, I'll just hit Control C. Now you can see host up, and it found these four, and the star here is just recognizing that that was the machine it was running on. Control C to end it. Now to pull up the code for the last Python script here. So again, you can see the same type of thing, breaking the header apart, setting everything up on it, and then here again you'll see where I'm using that if statement to set the port to the correct protocol. Pretty much the same type of thing as we've seen before. Now, what's different here is when it reads, as you can see, we are in a while true loop here. This will read it. It'll do the header information we just passed up there, and then it'll print out. What this will do is print out protocol, print out what protocol it is, and the source IP address and the destination IP address. And for this, you'll notice that the destination IP address on all these are going to be our machine. And then on keyboard interrupt, closes down the socket if you're on a Windows machine. As you can see here, I did the same thing for getting the local IP address and for setting up what type of packet type we're going to use. just so we have something to look at again, I'm going to set that up. And because this, I'm going to hold off for a minute, because this is a little bit longer decode. I don't know why in the world I blanked on that. Alright, so now it's listening. We'll come up here and fire this off. Of course, like I said, it takes about 10 seconds and it'll start going. And then down here, we're going to start seeing each of the packets as they come back to our machine. There we go. So you can see the 50.1, that's my router. And then here's an example of it, not finding anything. There we go, .10. If I remember right, that's my TV. So you can see each packet it finds is printing off that protocol, the source IP address, and then the destination IP address. And this will keep going until this stops. And to show you about the having to hit Control-C twice thing, we just come up here. So you can see it stopped, but we're still getting packets because that UDP sprayer's still going. So we have to come up here and hit Control-C again. Then this will stop down here. Okay, so that was just a quick little run through about the code from Chapter 3 about making a scanner and a sniffer using Python and using the socket library to set up your connections to listen to packets using tools like the IP address library on handling that information, everything like that. Really interesting little tools, especially if you haven't delved into those libraries, and it shows you some of the capabilities with them. So if it does interest you, I will leave links to the Python pages below about the libraries used in this, so you can go delve a little bit more. I'll also leave a link to the GitHub for these, so if you want to grab the code so you can play with it, you're more than welcome to. And I will see you next time.